So I was asked to talk about machine learning best practices, and there's not an enormous amount of time today. So what I thought I would do is just give a brief update on machine learning for COVID in general, talk a little bit about some of the major challenges, and discuss how the ML group is going to try to address this in what will be year 5 of CD2H. So I think I'm sure people have seen things like this, and normally I don't read from slides, but I think this is kind of important, so I'm gonna read this if you forgive me. And this is exemplary for a number of papers that have appeared that have reviewed the literature on machine learning and COVID-19. And this person, this author said that there are hundreds of papers claiming that machine learning technologies can use chest scans to quickly diagnose COVID-19 and accurately predict how patients will fare. And they published a study that he's introducing in the blog that I've linked here. And he said that his colleagues and I looked at every such paper that was published over a period of about 10 months. And so that would be 9 months, and found that none of them, not even one, produced tools that would be good enough to use in a clinical setting. And so in the paper that you can find if you follow that link, the authors describe first using a PubMed search and finding roughly 1,000 articles, and they pared that down to 250 some that were actually about machine learning for COVID, and they look closely at about 160, I believe. Oops. And so this is the paper, the one on the top. And it's very educational to, if your goal is not to publish a paper, but actually to do something for science or patients. And they do a very interesting and precise analysis of various deficiencies. And some of these are just the groups just didn't know better. But yeah, it's an interesting paper. A similar paper was published last year in BMJ, but this is being consistently updated. They didn't come to quite as devastating a conclusion, but almost. And this was about other kinds of models that were being used to predict whether somebody would have a positive test, or how well a patient would fare given that they are presenting with suspected or confirmed COVID. And they said almost the same thing. Almost all published prediction models are poorly reported and at a high risk of bias, such that the reported predictive performance is probably optimistic. And so why am I telling you this? Well, there's a pretty big need for best practices in machine learning. And because if we believe those two authors, then basically everybody's getting it wrong, or almost everybody. And so, if our goal is actually to use machine learning to do something useful, we should try to learn from those mistakes. And so, one of the goals of the machine learning group in the next year will be to provide some resources and documentation that might help a little bit, at least, to avoid some of those problems. Just to kind of introduce what we want to do, this is review material for machine learning, but perhaps not everybody has thought about this. So there, roughly speaking, are 3 big categories of generalizability. One is internal, so that basically means you take 80% of the data in your center, and can you make a good prediction for the remaining 80% of your data. If instead you train a model, let's say today, and apply it in 3 months' time, the question is, will it perform as well in 3 months' time as it did today? So that's temporal generalizability, and finally, external generalizability basically asks if the model you train at your center will work as well at another center, as well as in future time points. And here are just some things to think about, and why it's so difficult to make generalizable clinical machine learning models. And some of this is obvious, but I think it's still interesting just to think about it. And there's I cited a very nice paper in Lancet Digital Health that goes over this. So one thing is, if you're talking about temporal generalizability, that practice patterns change over time, and that's especially true for something like COVID, that where we're all kind of learning what to do. And so, for instance, the patient outcomes have been improved by any number of interventions that people have started to devise. And one example is low tidal volume ventilation. And so this will obviously affect the performance of models for how well somebody will do in the ICU, given all of their clinical and lab parameters upon admission. Another important thing is differences in practice between health systems. And so in N3C, we have well over 50 centers online or coming online, and so mortality predictions are highly sensitive to criteria for ICU admission across hospitals, to the populations that are served in hospitals. We have some centers that are have a larger proportion of pediatric patients, for instance. So all of this is obviously important. A lot of demographic variation is also obvious, and a lot of models that get published in countries with older populations might not work well in developing countries with typically younger population. One thing that I think we've had to deal with a lot in our platform is software variation for data capture, and the valiant efforts that many in our team have done to sort of harmonize data from the various centers. So that's an interesting paper if you haven't seen it. I'm going to switch gears and just talk a little bit about some work that that our group has been involved in. This is a collaborative effort with Justin Rees from LBNL, who I think is on the call. The group of Giorgio Valentini in Milan, a machine learner, and Lauren Chan and others from Melissa Handel's group. And so what we did was to develop a knowledge graph to represent the entities in the domain of COVID. And as you can see here, there are a number of things ranging from diseases in Mondo, phenotypic features and human phenotype ontology, medications in KEBI, gene functions in gene ontology Go, and pharmaceuticals in Drug Central and Pharm GKB and some other things. And what a knowledge graph does is basically to connect entities, so the nodes that you see here, with relations, such, for instance, the disease COVID is associated with phenotype ground glass opacity. That would be an HP term. And one of the things that we've been working on now for about 2 years is how to perform machine learning on graphs. And again, the same group that I mentioned developed a software called Envision that essentially performs a machine learning method called NoToVec at a speed of about actually more than 1,000 times the speed of the original implementation by Google, which essentially enabled us to substantially boost performance. And the effect of the NoToVec algorithm is that it embeds concepts, so ontology terms, in a low-dimensional vector space. And just imagine it's in 2 dimensions, like you see here. Actually, it's in 100. And the position of the vectors representing the concepts represents in a certain way their semantics. And so in essence, in our case, the closer a concept is to the term for COVID, the better we predict it as a potentially interesting medication for this. And we came up with a ranked list of repurposing candidates, and we then kind of did manual review of this list and saw that NSAIDs were highly represented in the top 100. What you're seeing here represents actually, this isn't machine learning, this is a statistical project where we show an increased, an association with increased severity and NSAID use. One of the things we found out in this this project was that actually an enormous amount of work is necessary to prepare the data for machine learning. And so there are still relatively substantial issues with data missingness, data coding, redundancies, and so on. And so one of the things that when we started the machine learning group a year ago, I think initially we were perhaps a little too quick to think that we would be able to quickly develop a lot of modular code to support machine learning. Initially in this group, we had, roughly speaking, 70 people. I think roughly half of those people have remained, and we've had a pretty active meeting about once a week. We've had hackathons, so basically learn-a-thons to teach people from the machine learning community about OMAP and clinical data, and to work with domain experts to teach them something about machine learning and coding. And I think we're now in a much better position, and we're planning to spend the final year of this project creating a series of best practice documents, some additional software, and essentially our goal is to have start to finish deeply documented tutorials for doing things that are necessary for good machine learning. And I'd like to call out Joanna Lumba, who is leading this part of the work, and we will be providing guidance on how to process data before machine learning. And this includes things such as data cleansing, imputation of missing data, investigation of whether data is missing completely at random, in which case, roughly speaking, you don't have to worry too much, or whether the missingness is associated with another clinical factor that you're interested in which case you do have to worry a little bit more. Another issue is that a lot of the data that is available in the platform, and this is sort of technical software engineering, is not always in the form that is most amenable for downstream processing. And for instance, this can be the case where a certain data is not represented as a Boolean true false, but is represented as either a string or a null value. That's something which typically doesn't work in downstream packages and requires transformation. And so we will be basically providing examples and guidance on how to do that to basically retain as much as possible of the data. So here are some details. I think I can skip that here. And maybe one thing I will mention, this is something my group is working on, is the LOINC to HPO library. And so lab values are typically represented using LOINC codes. And this is fine, but for machine learning, one of the difficulties of using LOINC is that the codes are very redundant. So for instance, there are 20 different codes for blood sugar. There are 4 codes for something I'm forgetting right now. And our library essentially semantically harmonizes all of these codes into a qualitative assertion as to whether the result was abnormal or not. So, for instance, if any of the 20 Loink tests where blood sugar is above normal limits, you could use the HPO term for hyperglycemia, and so that's something that we will be providing. Another thing that we'd like to do is basically provide deeply documented start to finish pipelines for machine learning. And those of you who do machine learning might be saying, well, why are you doing that? There are already tons of tutorials online and so on, and that's true. But we do think that a lot of to actually perform machine learning at a high level on the platform, there are a lot of things that are sort of special to this platform, such as the feature selection and just use of the platform that I've been addressing that we plan to look into. So we're going to be doing two exemplar projects. One of them will essentially be using 3 classical ML models and showing how to assess temporal and external generalizability. The other one will be using deep learning models to support clustering of patients, this will be sort of a little bit more advanced machine learning, and this will become possible if the Azure platform goes online. Okay, finally we're planning on doing outreach. So if we're allowed to, we may come back to this group in some time, and we will also be trying to work with a number of the other smaller groups throughout N3C who express interest in these ML solutions. So I'd like to thank especially Justin Rees, who's been my partner in crime for, oh gosh, over a year now in all things N3C, Joanna Lumba, who we're starting to work with and very much looking forward to the next year. If any of you is interested in joining our group, we're meeting bi-weekly and until the contest, the competition is over, and we'll probably go back to a weekly schedule after that. Thursdays at 11 a.m. Eastern. So thanks for listening.
Great, Peter, thanks. Any questions? Anything in the chat? So Peter, well, let me ask you a question. So what's your sense and what's been your experience in terms of using ML for data cleaning? I know that's been discussed in N3C and in the world. Is that something that you think could be profitable?
So if you use a standard R package called mice, essentially what happens if, let's say you're looking at BMI, which is often missing, and you'll have 30 other covariates. You'll essentially use those covariates to predict the missing value. And you can do this by a number of ways. You can do something which is essentially just a regression, or you can use something that resembles a random forest and just kind of replace that value. I think there is no clear winner, so there's no advice that you sort of always have to do it this way. But what we'd like to do for this tutorial is sort of to show how to set up a number of competing ways of looking at data missingness. What kind of graphical output and statistical descriptors do you get from these procedures? And sort of roughly speaking, how do you decide, given that, which procedure you should use for your data set?
And so what about mapping to HPO? I mean, so we've at Stony Brook, we've done a certain amount of using different ML type algorithms to look at noisy data and try to decide who actually has particular clinical phenotypes. And I'd imagine that would be very useful for mapping to HPO.
It can be. I would like to call out Tiffany Callahan, who's done amazing work that has helped us to use HPO in some projects I didn't mention here. I would say, though, that currently we're not gaining much advantage from using HPO because we're not fully taking advantage of the hierarchical structure of HPO. And so what we're doing now is basically finding UMA codes that correspond to a given HPO term for things that are not typically represented in one place in the EHR. I think one of the things that we think might be useful is to use a sort of a more sophisticated algorithm that would take advantage of the HPO hierarchy to calculate things like likelihood ratios of phenotypes given diseases or vice versa to make a diagnosis. This is something that we've done in rare disease, and that's something which is sort of up on the slate for this coming 12-month period.
Mm-hmm. Cool. Okay, well, thanks. Am I missing a question? I don't see any other questions. Okay. All right. Well, thanks. This is a really great talk, and it's very exciting work. Looking forward to the next year. So Hongfang, it's over to you. Eager to hear about status of NLP.
Can you see the screen?
Yep.
Okay, just a second. I need to move this. So we come here for some progress report related to the N3C ML working group, and just want to emphasize this is a community effort and informed by open science and AI ethics for clinical research. It's a collaboration between Open Health Natural Language Processing Consortium and the CD2H NLP group and IEC Text Analytics Working Group. So a lot of you see this before. So we have multiple active participant sites, and the operation support has been wonderfully given by Rafael for this. And the piece we keep engaging the community. We want to get more sites being excited about our agenda and also activities here. So dissemination side for the N3C ML, currently we are disseminated through Apache license version 2.0. The GitHub page gives you some documentation related to the N3C ML activity. At the same time, we do have through CD2H NLP side, we have the NLPSandbox ready for the community to onboarding. We've been giving in the EMIR 2020 as a panel. We participated all the community call related to this for the activity. We have a coming workshop in the EMIR 2021, which is the end of this month for this activity. And we have a manuscript in pre-submission stage. And this is a manuscript on behalf of the N3C ML working group. So let's go to details. So what we have been working on and what are the things we plan to do in 5th year. So a lot of you probably noticed in the N3C enclave, currently we still don't have the, actively using the NLP data. Many due to only limited sites have contributed the data there. I think 2 to 3 sites, we're hoping to have more sites to get there so that we don't have the issue of, site identification issue. Why we need a clinical NLP for this N3C enclave, N3C effort. And just to go back to the clinical documentation itself, most of the documentation follow this subjective objective assessment and plan. If you look at those items, chief complaints, history, present illness, history, review of system, current medication, and allergies, a lot of such information are not in structured data. Objective side, pretty much a lot of them are available in structured data, but the imaging results, the same thing, you may not have that available in structured data. And also review of documentation of other clinicians. Most of the time, you will not see that appearing in your structured data. And there's the assessment and the plan. Those are the things we generally view as the contextual information for structured data related to the clinical decision making. So just keep emphasize, it's so important to have the text clinical NLP, and so we can get the text clinical information out to the unstructured EHR data, and so that we can have more comprehensive information about the patient encounter. And this has become even more crucial. We view some of the reproducibility issue we face related to clinical research, related to predictive modeling, a lot of them due to the fact that a significant amount of information about the clinical encounters are not truly utilized. There's the gaps due to non-standard documentation reporting, and also disease and differential diagnosis. And the majority of the time, for example, diagnosis codes was used for billing purpose. That whole events that diagnosis may not be even true diagnosis. So go back to the reproducibility crisis of a secondary use of EHR. We believe the clinical NLP is a missing piece, and we actually do want the community to pay attention to this, and we do want across the CTSA, across the consortium, try to pay attention to this. So we do want to say the reproducibility, not just the foundation of trust science discovery, and it is also, you know, how can we adopt the open science type of principle to handle that, where the how do we obtain consistent results when using the same data methods or tools, but now come to, if your methods of getting data, of your methods of if your data are not available, the methods to get data are not consistent with each other, we also face the reproducibility of the data issue there. So this is next, basically just to keep emphasize the reproducibility and validity challenge associated with secondary use of EHR for clinical research, as well as for predictive modeling. We are missing the contextual information about the structured data, which most of the time is available in unstructured documents. But getting unstructured documents from the secondary use perspective, we face a lot of, you know, kind of challenge. There are different stakeholders faced, we need to tap into. There are different technology resource challenges related to system infrastructure, database, and information. So from, you just look from left to right, there's, you know, practice variation, definitely EHR heterogeneity and complexity. I want to emphasize this one a little bit. I'm fortunate to be able to experience a EHR migration in our local institution, Mayo. And we see significant difference between two different EHR implementation for the same practice, where the data capture and the text data, they all have a dramatic difference. We also face, in a situation of N3C, we face the issue of data access kind of arrangement issues. So we don't have text data, clinical notes available in the enclave due to the HIPAA privacy concerns associated with the text data. Of course, data analysis part, if you don't have data and code sharing, it can be quite challenging. The last one is reporting, and the lack of standards for reporting. So all this translate to this, we have the outcome variability across different kind of sites, and we also have information accessibility and the process transparency, which are so crucial to be factored in to explain if there's lack of reproducibility. Is that due to what reason? Due to the variations, or due to the lack of transparency and access? Just go to next slides. So, but meanwhile, everyone here probably say, okay, NLP is hard, it's hard. The reason it is hard, however, our end goal in the clinical domain is that giving me text data, I will change it to a structured representation. And in the common data models, OMAP type of model perspective is the standard terminologies. We face the issue with the intrinsic challenge faced in semantic processing, which is related to what you call ambiguity, synonym, and novelty. However, we also lack of contextual information standardization related to clinical documentation. So as I mentioned, in Cerner system reports is dramatically different from Epic notes, and it's also probably different from other EHR systems documents. And the second is the gap between text semantics and expert semantics, which is here means that when you remember the documents was provided to be used for communicating between the care team, and there is a context about that documents. And most of the time when you do clinical NLP, you just look at the document as a document, and you don't factor in what in what context that document was created, for what purpose, those type of things. And also we don't truly have a documentation standards widely deployed implement. Historically we have, for example, HL7 clinical document architecture, which kind of one standard. Then we go to document ontology, then we go to FHIR related standards related to documentation. But all those are sometimes, maybe you can, EHR system adopted, but not consistent adopted them. So in general, we view this as an AI hard problem. If someone come to us to say, we have a clinical NLP system for you to deploy for everything you do for your clinical NLP use, I would not trust it. We view this as an AI hard problem, but we can leverage lead binding and human in the loop, make it possible to leverage the clinical NLP for clinical research. I will get to some details later. So in the clinical research community, generally whenever they talk about clinical NLP, a lot of times they talk about a much broader definition of natural language processing or text analytics. Sometimes they view document classification as kind of NLP. Information retrieval may consider as NLP, or concept extraction, information extraction, all those different pieces. View as natural language processing, and as a discipline in itself is multidisciplinary. I want to emphasize the challenge we also face is that currently some of the clinical documents itself, they are not truly natural language. They are generated through probably auto-populated from structured data fields, or they have some templated boilerplate structures. So sometimes the clinical NLP system, if we truly deal with natural language processing, they may have a challenge for processing those without knowing the structure. Go ahead, next. So in the context of N3C, our purpose is for augmentation. We are aiming to extract clinical concepts from the text data, and through that we augment the data to data capture and used for the analysis. This is giving you an example in what is the information extraction is that I give you a text data and I try to fill a template, which is in this specific example showing silent brain infection, where's the what's the template we try to fill by giving this reports. And now the task is that you need to define first what kind of information template you want to extract. Secondly, you need an approach to extracting them. The approach to extracting them come to two different kind of approach. We do have rule-based related approach, which is through what we call corpus analysis, through the knowledge engineering and rule development. We also have statistical training and approach, which is through the model training and optimization. So when we go to the second approach, statistical training, we actually face some issues too, which is reflecting to Dr. Robson's talk regarding the reproducibility, generalizability. Of course, you finally have evaluation. So this process probably, no matter what, require us to have gold standard. But let's go back to something I've been observed as a clinical NLP researchers. I've been doing this clinical NLP research for over 20 years. But a lot of times this is, we view a misalignment of clinical NLP research and the NLP needs from the clinical research. So this is go to the things which is called real world use of a technology, which is try to help people. I want to call out something related to on the clinical NLP research side, we are focusing on how do we have breakthrough innovations? How do we ensure, the publication get published with the state-of-the-art performance? This is really aligned with something when I go back to this academic of health affairs article, which is trying to illustrate why isn't innovation helping reduce the healthcare cost? Why we're not get to value-based care? Because across all the different stakeholders, our focus more on the reward the innovations, which are, can get funding or can, get media attention, but not too much about, optimization and improvement. So another thing which is make us think dearly to our heart is that when you use clinical NLP to enable clinical research, if you do something wrong on the extraction side, the data generated from that may have some societal impacts. For example, you're missing a critical data elements, which may only appearing on some nodes related to social disadvantaged team. Secondly, we all know those that the clinical NLP itself is quite expensive. If we don't go for transparency and general availability to everyone, we face the documents from, for example, underserved population or sites with limited budget. They may not have the text data and the concepts extracted and make their data not fit for analysis, then you exclude those from the analysis. So all those giving us taking a different look at our problem. So basically, we are looking at it not from a clinical NLP research perspective. We are looking at it as real world NLP implementation to empower clinical research. So this has been something towards this, the validity and the trustworthy component associated with clinical NLP. We view the task why sometimes getting challenging if you want to ensure scientific rigor. Yeah, it is quite expensive because you need to go through the whole process of the development life cycle related to AI algorithm development or machine learning algorithm development, which is involve data curation, annotation, resource creation, and from that you do the multi-site deployment, performance monitoring, evaluation. And this is the piece we call a trust process. You need to allow your text data accessible and retrievable. And this is not enough. You also need to use that to help with improving the scientific rigor and the trust with clinical research. So I've used this principle to guiding our, clinical NLP activity, which is more from the FAIR principle and also the implementation principle as the right principle. And with the goal of hope, trust, and science behind it, a lot of clinical researchers, they are struggle to get the data out from the text data. They said this is just, when they do chart review, it's there. However, can you systematically pull that for us? Sometimes it's just a single data elements there, where they want to get things out. And but they don't have the computational skill sets, and their NLP colleagues may not be interested to do that either, because it's very trivial. You cannot have a scientific publication out of it. Anyway, so those are the principles we follow with the pieces that we want to bring hope to the clinical researchers. We want to build a trust and to indicate in their value added from the clinical NLP. And we, of course, most important, we needed to build evidence that the EHR can be leveraged for clinical research if we take advantage of both structured data and unstructured data. And so this is the development work has been carried out among the team here, where we want the trust process of gold standard creation. We are adopting a people-centric evidence-based approach for model development. We also take advantage of federated implementation, respecting institution variation and privacy policy. And this framework currently available for adoption. Detailedly, this is also a cloud-powered architecture. If sites are, you know, are cloud-friendly, and we also have some of the demo servers available in the NIH cloud. And to simplify the benchmarking data sets creation, we also getting something called serverless annotation tool for gold standard creation, so each individual sites can do their benchmarking. This actually has been tested by multiple users, and we view this can be greatly accelerate the gold standard creation for low resource sites. And it's a serverless, which is indicating you can run it without really need your institution IT to clear up the security. And it's ready to use as soon as you get that a tool. Meanwhile, this is the NLPSandbox through the CD2H NLP effort and IEC text analytics team. We actually they set up this sandbox, and which we are not forgetting about the state of the art in NLP advancement, but we want to do that through some of those through this kind of challenges on the benchmarking, where it's a federated evaluation framework empowered through the cloud infrastructure approach. And the cloud, this partner institution A or partner institution B, those are behind the firewall. And this way, you actually can get the state-of-the-art NLP tools to be used. So we call for more sites to join us. We believe the validity and reproducibility and all the issue you faced by predictive modeling and by clinical research reproducibility challenge, those are due to the fact a huge chunk of information are not used. You have incomplete data there. And we are hoping we follow an iterative process towards improvement optimization. Basically, you know, it's an agile process. Don't expect this is going to be perfect from day one. But I think as a community work together, this can be done. And also don't let perfect be the enemy of good. Some data elements, you may not get that right and get you know, certified performance, but it's still okay. We work as a community to get that information out. And it's the most very important, since we are talking about the multi-sites and a community effort, we do want to go together, then we can move to truly harvest the power and the data, power of the, you know, the EHR data for clinical research. And so this is what we envision for the 5th year. We try to do some piloting, but moving forward, we envision the development moving beyond COVID-19 is that the whole framework we set up is a generic framework for any kind of cohort study or multi-site study. We envision the clinical NLP research community and the clinical translational science research communities through this kind of community-wide effort. We hope to bring the people together so that, you know, we have more comprehensive information from the EHR to enable us to do discovery. And so this is almost all the pieces that we mentioned before. It's a part of here. So we want to go take advantage of the clinical research community, clinical NLP research community, to do the benchmarking and to do share task challenging. And we want to leverage the framework we developed here to enable local sites, institution installation. Then this is an open, you know, available through Apache. Where we for whoever onboarding, we help you set up this backbone installation. And we also have a lot of you know, best practice materials available in the wiki. We have tours available for adoption, and I think this is the last slide. Yes, and we also have the you know, the office hours and the group meetings is on Thursday. So take every other week. I mean, this week is a group meeting. It's 2 to 3. And then we have some active projects going on. One is related to, you know, social determinants of health information concept extraction, long COVID concept extraction, and adverse events, vaccine adverse events extraction. We also think about the core NLP challenge tasks related to de-identification, also related to contextual semantic annotation task. And that's all I have to share, and do hope more sites join our journey.
Well, that's great, Hongfang. That was a really great and comprehensive talk. Are there questions? So, okay, as usual, I have one in comment. So I think that, you know, clearly this issue of validation across sites is critical, and I'm really excited to hear about the tools you're developing for that. Obviously, one of the issues is to essentially decide how to prioritize what to validate. Mm-hmm. So what are you pushing right now in terms of, you know, in terms of N3C, what different sites are actually working together to validate?
So validation always come, you have gold standard creation, and currently you know, the size, when we've been pushing some of this with some sites volunteering their effort in those kind of effort. When you talk about validation, you talk about NLP algorithm performance validation, or you're talking about the process validation?
Well, I guess what I'm talking about is you have N sites and everybody agrees that they want to extract, say, 10 consistent concepts. So let's say, for instance, you're looking at long COVID and, you know, basically brain fog or sort of trouble concentrating or whatever it happens to be. You say, okay, we're all going to look for this in notes. And so obviously you have to decide what words you're going to look for, what phrases, you know, make sense. And then to actually have each site mark up, you know, gold standard ground truth and see whether we're able to do it.
Yeah, the piece is all related to the size, we have currently the 6 sites help with contributing what we call synthetic de-identified clinical notes and help creating the gold standard. So some of those sites data actually available in that pre-submission manuscript, which is showing how COVID signs symptoms extraction to be done. And the social determinant of health, we are just going to be kicking off, but this has come to the pieces. We are asking people for volunteering their team for doing those tasks. It's not going to be easy. They are interested, but the piece, they always come, you know, can you have funding for us to do? This is basically majority of the size. If I'm not mistaken, the text analytics capability, the team are actually not there. We want to help sites to train, but it still come to the, you know, they need a resource to do the task.
So do I understand, so the serverless annotation tool for gold standard creation, if I have the right name,
Yeah,
you talked about, so is the intent of that is for sites
to create a gold standard? Yes,
their own gold standard. So presumably in terms of validating across multiple sites, since you can't see people's PHI and de-identification as people, then presumably each site would mark up their own notes, and then so you have a bunch of sites doing that already, or
this tool just fresh out of the team. So in the last 3 months we've been doing this. So we noticed a lot of tools, annotation tools are require some installation, and also some are web-based. They face the issue of how to get a clearance from their institutional security to do that. So we end up doing a serverless type of annotation, and it will be appearing on the GitHub for release soon. I think we are ready.
That's great. So then for long, just one last thing, and then we'll, so then for long COVID, because of course there's a lot of interest in that, both clinical notes as well as, my own interest, imaging notes, typically people aren't necessarily, used to generating notes for that sort of thing. So there'd be a lot of heterogeneity. So then would you anticipate that tool would be, potentially useful for groups who might be working together to extract text involving long COVID?
That's the goal. That's actually try to get sites to commit to that effort. We do have the annotation guideline provided, some example provided, but this is all come to voluntary effort. The annotation effort is not cheap. I just for almost all the machine learning AI efforts going on, the data generation is the most expensive component.
Oh no, we know that. Well, this is fantastic. So I see.
Hongfang, I just want to say, this is Andrew from Tufts. We will participate and help with the work that we're kicking off in social determinants. And I just encourage other people who are listening, representing from their own sites, to do so as well. It's been extremely beneficial. You're just going to get a lot out from whatever you put into this. It's certainly Tufts is benefiting quite a bit from participating in this, and so apart from monetary support, there's other kinds of rewards that come from participation. I just encourage as many people as possible to join in, and you'll get the best out of it.
Oh, absolutely, and I know Janos has been working with you from our side.
Yeah.
So no, it's a great effort, and certainly as we all ramp up to look at post-COVID sequelae and the like, it's going to be that's something that many of those many of those symptoms are not going to be coded very well in discrete data elements. So that's going to be key.
Yeah, I think one thing I want to emphasize is not just COVID. And I think the sites, if you deploy this framework, you can supporting your local clinical researchers to do to get information from the text data so that they can use those information for their research. I know some of the clinical researchers struggled with text extraction, chart review. This is a systematic approach to get your charts to be reviewed. Instead of like 6 months to review every chart for 1,000 patients, you probably only need to spend about 1 afternoon to get the data needed for your research.
Yeah, no, that's great. Well, thank you. And so I have an announcement. If I can share, I have a little slide. See it. EHR data quality is coming up. So we're looking forward to that. So we're going to start introducing the next week's presentation. So thank you. Any last comment? Yeah.
Yeah,
go
I'm
ahead.
sorry. Hongfang, I just want, first of all, thank you. This is, from my point of view, from NCAT's point of view, we know how important the notes are, and yet it was just, trying to figure out a way that we could generalize this is just so important for us. We'll never be able to do it. So I just thank you so much. I do want to ask you a question on how we can help. The question is I'm wondering, do you think that folks understand, and including myself, that the data is, the extraction is of codified, will codify the elements, so there is a very extremely low risk of PHI of getting into this. And I'm wondering, do you feel like that's I don't know, a rate limiting step, that people don't understand that, and how can we help get that message across?
Yeah, I think that's just to try to go back to the fundamental, the structured EHR through the CTSA funding, people all have this clinical data warehouse there. Since text data not really a requirement, majority of the sites may not truly have this kind of text data, even explore the possibility to get into clinical data warehouse. So I think that's one of the reasons why sites are, why we are not getting like 10 sites, 15 sites here, why we only have 3-4 sites currently running through this. And in general, there is no, so that this is the whole thing is that there's no PHI information ever truly be exposed just through this, deploy this framework. It's a federated NLP framework.
I'm wondering if there's a way to do a presentation to help you, or help the community understand that better, because I think people are still, you just say NLP and they turn around. And so I feel like we need to figure out a way to help you. But anyway, I thank you so much. I think it's great. And I just can't agree with all the things you said. It's a tremendous effort. Thank you very much.
Thank you.
All right. Well, thank you, Hongfang and Peter. This was a great session, and everybody have a great week. And we'll see you next week, and probably before. Thanks.
Bye.
Thanks, everybody. Bye-bye.
Bye-bye.